Okay, so this is part 2 of the video I'm making of the portfolio. So we are going to focus on number 5, the actual portfolio that's been asked of you in the tutorial letter. Now they say here that the scientific process is a way of investigating things about the world. Scientists use this process to find out about the world and to solve problems. Okay, now this thing written in green, it's in your tutorial. It says follow the steps below and compile a portfolio of evidence showing the scientific process in the 2 experiments above. In other words, those 2 blue ones. Please take this sentence out of your portfolio. It doesn't say that part there in your tutorial. I'm telling you this. So basically, your portfolio is going to look like that. It's going to start there. It's going to look something like this. Okay, I've made this. I've edited like that. But that is how I interpret. If you interpret it in a different way, then you're more than welcome to share that with us. I'm just assuming they want us to now do experiment 1 and do experiment 2. Okay, so this is how you basically going to take all of this out. This is still going to be part of the top part of the purple ones. Then you're going to start off with a new page which includes this. So let's look at experiment 1. Experiment 1, and you can read with me on that blue. It says electrical circuits with resistors in series and parallel, measuring potential difference and current. Now, before I'm going to explain the actual step 1, 2, 3, and 4, I want you to understand what does it mean, all of those words. Let's just define the words first. For instance, let's define electrical circuits, let's define resistors, let's define series and parallel, potential difference, and current. Please take note, you will not be asked these definitions, but you need to understand this in order for you to answer the questions that follow. So these are going to be a little bit of a science class, but I'm going to try to make it as simple as possible for you. So I'm just going to turn my video around and you will see I've also sent this on WhatsApp for you on a photo. So just these 4 photos. Actually, yes, 1, 2, 3. There's 3 photos that I sent through. Make sure you open this one when watching this part of the video. So let's define an electrical current because that's the first word in your sentence asked for your experiment. A definition is an electrical current is the rate of flow of electrical charges in a circuit. So basically, let's say I've got a little light bulb. And I've got a little battery that is connected to that light bulb. Remember, every time you put your battery in, they say put that little thing to that side and then the flat should be on the other side. There's a reason for it. Now that current, if I have, let's take a color Cokie to show you this. If I have a current and I go through that whole circuit, that is my current, my electrical current. In other words, in basic language, everyday language, that's my electricity. That's the thing that will make you shock when you just open up a little piece of wire, and then that is the live electricity flowing. So that is the current. If we refer to current, that is the current. Okay, then there's little things there that I don't want you to understand now or to worry about, really not ever, only if you're going on into science. For now, I just want you to understand that the thing, if we can call it like that, the thing, the charges, that orange thing that flows through the circuit, that is the current. Okay, the next word that we also come across in our experiment is electric potential and potential difference. So this is a new photo. Okay, so if you read that with me, it says batteries lift charges to a higher potential and there's a potential difference because each column of charge has a different potential energy at either end of the battery. Whoa. Okay, don't worry about anything I just said now. Just understand that the electric potential and the potential difference is basically the volt. In other words, what is the strength of your electrical circuit? How bright will it let your light shine, or how dim will it let your light shine? Okay, this is very basic, but I want you to understand basic now. Okay, so if I talk about potential, electric potential, or potential difference, it means the way in which your circuit is made up, so that it will either make your lights brighter or dimmer. Okay, now let's look at the two types of ways that it can be. Your potential difference can either be, or your resistors can either be, bulbs is resistors. A resistor, basically, if you look at the word resistant, if something gives you resistant, it hinders you to do something. So the bulbs in a circuit, a little light bulb, is like a resistor. So when the current, which we just defined, flows through that bulb, it means it will take a little bit from it. So it's resisting the current. Okay. So these bulbs can either be placed like this. So you'll have one bulb and the flow of the current will go through, and it will go through the first one and it will go through the second one. And that is called series. It is the way in which the bulbs are placed in a circuit. Okay, then you also get parallel. Parallel, and you can also, actually there should be a line, I think it misprinted. Parallel is when, look at this now, my circuit doesn't go through both. It goes through that one on its own, and it will go through that one on its own. Can you see it's on different paths? It's almost like two cars are driving on the same road. That car drives left, and the next one is going to go on a little bit further and then only turn left or right in this case. So can you see the difference? So series and parallel is referring. It is referring to the way in which the resistors, which in this case is the little light bulbs, is laid in the circuit. In other words, the way that it is connected. This bulb is connected in series because it's in one line. Parallel is not in one line. It's in the same circuit, but it's got its own line. So this is the part that makes it a little bit more scientific, but you need to understand this in order to understand why a certain thing happened. Okay? So when I'm talking about series and the bulb is fitted or connected in series, my resistors will just be added up. So let's say that is 1 ohm and that is 2 ohm. It will just be 3 ohm. But in parallel, if I have the same one, I also have 1 ohm and 2 ohm for the parallel. Can you see it's going to be less now? It's going to be 1 over 3. So can you see it goes down from 3 to 1 over 3. So already you can see that just by looking at this mathematical equation, that to fit or connect your resistors in series versus parallel is going to have the difference with regards to the resistance. The resistance is going to increase with bulbs or resistors in parallel, and it's going to decrease. So if you look at this little picture that I've sent to you, you will see that these bulbs are connected in series. Okay, the second one is in parallel. Okay, now why are parallel connections preferred over the series? So you can go and have, well, you can't really go and have a look because you're not electricians, but you can ask an electrician. Your lights, your microwave, your kettle, everything is the preferred way in which it is connected is parallel. And the reason for that is, let's say one of this little bulbs break. Then if that is not there anymore, the current cannot flow. It stops there. But let's say this little bulb in parallel is broken up. It will go there and say, oops, okay, I can't go there, but then I can go there again. Can you see the difference? If something hinders this series, one of the bulbs breaks, then there's a shortage of electricity current. Then there won't be power. However, if it is in parallel connection, if one of that is taken out, it can still have another option of another route. Okay, I'm going to pause there, and then I'm going to send you another video explaining what happens with series and parallel with regards to the advantages and disadvantages.